Now, coming to the next periodic properties, we will see the next periodic properties is electron gain enthalpy, which you studied in lower classes as electron affinity. We can say that. Now, why do we call it as electron gain enthalpy? There we studied electron affinity. Now, when we say electron affinity, then the idea is not clear, because electron gain enthalpy, the definition is, it is the amount of energy released. It is the amount of energy released, means it's an exothermic reaction. It's defined as the amount of energy released when a neutral atom gets converted into what you can say, into an anion by accepting an electron. Alright? So in other words, we can say it's the amount of energy released when a neutral isolated gaseous atom accepts an electron to convert it into its anion is known as electron gain enthalpy. We can say that. It is the amount of energy released, means it's an exothermic reaction, when a neutral gaseous isolated gaseous atom, I said you isolated means what? Single, we can say that. Gaseous, I said you, because in gas the atoms are far apart from each other, so it is easy to gain electrons as well as easy to lose electrons. So here it is going to lose, not here it is going to gain, not lose. Alright. So when an isolated gaseous atom accepts an electron, so when it is going to accept an electron, it is going to convert into what? An ion. Alright, to convert into an ion, a negative charge, we can say that. For example, I can give in general x plus E minus will give you x minus. So this is known as delta Eg. Delta Eg is what? It's a symbol used for electron gain enthalpy, we can say that. Delta Eg. Alright, we can say that. In this way. Or you can write it as also, in certain books you can see, you can write it as delta EgH, because enthalpy means heat. You'll be studying it in this class 11 only, that enthalpy means heat calculated at constant pressure is called as enthalpy. Alright? So it is simply known as heat, we can say that. Clear? So in this way, when an isolated gaseous atom, this is an isolated gaseous atom, we can say that, it accepts an electron to convert it into its anion. That is known as the amount of energy which is released. That is known as what? Electron gain enthalpy. So it is released means it is what? Negative. So here delta EgH is nothing but is your negative, you can say that. It is an exothermic reaction, so to say. Clear? Now, I was saying you, why do we call it as enthalpy? Because see, now the idea is quite clear, it's the amount of energy released. But when we say electron affinity, affinity means what? It's just a tendency, we can say that. So hence, a new term we have come to is electron gain enthalpy. And moreover, here, electron affinity, when we say, it is understood that it is a tendency simply. So there we cannot understand what should be the unit. But when we say electron gain enthalpy, that means enthalpy means we know heat, and heat, the unit of heat is nothing but, we can say joules or calories or kilocalories, because heat is nothing but a form of energy. So hence the new term is nothing but electron gain enthalpy, we can say that. Clear now? Gotcha. So hence you understood it is the amount of energy which is released when an atom gains an electron to form an anion. In simple words we can say that. Clear? So now when you move from left to right across a period, electron gain enthalpy increases. Mind it. When you are moving from left to right across a period, that is delta EgH, it is increasing when you are moving from left to right across a period. Why? Because the nuclear charge increases. So electron gain enthalpy increases, we can say that, when you are moving from left to right across a period. Similarly, when you are coming down the group, that is electron gain enthalpy decreases. When you are coming down the group, it decreases electron gain enthalpy when you are coming down the group. Because when you are coming down the group, electron gain enthalpy decreases because the atomic size, we can say that, it increases. As atomic size increases, so electron gain enthalpy decreases. See, when the atomic size is going to increase, I told you in the previous properties also, when the atomic size is going to increase, then it is not only easy to remove an electron, but also it is easy to add an electron to it. because when you are coming down the group, what happens? Atomic size increases, as well as the shielding effect or the screening effect, that also increases, we can say that. So it is easy to add an electron to it, we can say. It is easy to add an electron. Now where will add an electron? Definitely to the outermost shell only. Definitely to the outermost shell we are going to add an electron to it. So it is easy to add an electron to it. So as it is easy to add an electron, for that purpose what you find is that electron gain enthalpy decreases when you come down the group, and when you go across a period from left to right, what you find is that increases, because again the same thing, across the period is affected by the nuclear charge. As the nuclear charge is increasing, the atomic size becomes smaller and smaller. Alright, so hence what you find is that, so the electron gain enthalpy, tendency to gain electron, it is increasing. Tendency to gain, if you understand in other words also. Now when you are moving from across the period, what happens is that the number of electrons is increasing in the outermost shell. Alright, so when you are moving to, when you are going to group 17, how many electrons is having in the outermost shell? 7 electrons it is there. So to become stable, how many more electrons is required? Just one more. Group 16, how many more electrons is required to become stable? 2 more. Why? Because group 16 has got 6 electrons in the outermost shell. Group 15 has got 5 electrons in the outermost shell. So hence what you find is that 5 means it requires 3 more. Now 6 means requires 2 more. 7 means it requires 1 more. So what you find? That when you are moving from left to right, that is across a period, that is tendency to gain electron is increasing. Why? Because after gaining, what it will become? Stable. It is going to become stable. Even if it is converted into its anion, but it becomes stable in nature. In this way, what you find is that when you move from left to right across a period, alright, atomic size decreases, nuclear charge increases, the tendency to gain electron is increasing. So hence for that particular reason, remember it, group 17 elements, that is your halogens, are said to be having the highest electron gain enthalpy or highest electron affinity, we can say that. It has got the highest electron gain enthalpy and the highest electron affinity. So generally what you find is that group 15, 16, 17 onwards it increasing. Alright, because here it is having a tendency to gain. Because group 1, 2, 3 means it is having 1, 2 or 3 electrons in the outermost shell. So definitely already in lower classes it has got a tendency to lose, to attain the stable configuration. It has got 5, 6, 7 electrons in the outermost shell. What is having its tendency? To gain. So hence for that particular reason we can say that when you move from left to right across a period, it has got tendency to gain electrons. So hence electron gain enthalpy increases. I hope you got it, this particular thing. That when you are having 15, 16, 17, I said you, it has got 5, 6 and 7 electrons. That means it requires 3 more, 2 more, 1 more. So hence what you find is that if you get 1 more means stable, 2 more means stable, 3 more means stable. So attain stability, everything is being done. Alright, so hence tendency to gain electron is increasing. Now you will ask me, what about group 18? Group 18 is already fully filled. It is fully filled, outermost shell it's fully filled, it is stable already. So it has got no tendency to gain electrons. So its electron gain enthalpy is 0, we can say that. It is 0 or highly positive. How it is positive? See. Now that is, let us say we are having neon whose atomic mass, atomic number is 10. So it will be 1s2, 2s2, 2p6. So outermost shell how many? 8 electrons is there. And the first shell how many? 2 electrons. It has got 2 shells, 2 and 8. You can see that. Fine. Now, if you are going to add electron, first of all, it has got no tendency of gaining electrons because its outermost shell is fully filled. Second shell fully filled. So it has got no tendency. But still you want to add an electron to it. Listen carefully. So if you still want to add an electron to it, what do you have to do? You have to supply energy to it. You have to supply energy because you have to bring that atom to the excited state. You have to create an extra shell. Because when you will supply energy, by gaining energy, an extra shell will be created there. An energy level will be created there. Then only you will be adding an electron to it. Alright, so what I said, you have to supply energy to it. You have to give energy to it. A huge amount of energy has to be given. Then only it will come, what you can say, to the excited state. And once it reaches to the excited state, what you find is that, then the electrons will jump from this state to the third level, we can say that. From the second level to the third level, the electron is going to jump by gaining that much amount of energy. So hence you can add an electron to now in the second level. We can add an electron where the what you can say the vacancy is being created. You can add it to it. Alright. So in this way it is highly positive. So many people they say that electron gain enthalpy of noble gases is 0. Correct, absolutely correct, because it does not have any tendency to gain electrons at all. Its outermost shell is fully filled. It has got no tendency to gain electrons. Some also say that it is highly positive. Got it? Now the reason why it is highly positive, because if you want to add an electron, then it will not going to, because it is not having tendency to gain any electrons. So hence you have to add an extra amount of energy to it, not small amount, a huge amount of energy has to be added. Then only that level is created and the electron will jump from here to that third level. So the vacancy which is created, in that you can add an electron. Alright, that's it. In this way you can find it out that electron gain enthalpy of noble gases is 0 or highly positive. Now what I said you that electron gain enthalpy is negative, but here you can see it is highly positive. Alright, in case of noble gases, find it. So in this way, next is the first electron gain enthalpy of any element is negative. Listen carefully, I am talking about successive electron gain enthalpy. Successive, one after another. Suppose it gains one electron, then after that it gains another electron, then after that it gains another electron. That is called successive. Alright, so in case of successive electron gain enthalpy, the first electron gain enthalpy, as you can see, it is negative. Alright, now let me give an example to you. For example, let us say I am taking here, that is nitrogen. Now nitrogen gains an electron to form N minus. The first electron gain enthalpy, that is delta EgH1, is nothing but negative. No doubt about it. Alright, no doubt about it, it is negative. Fine. Now next, after that it gains one more electron. Which is going to gain now? N minus is going to gain an electron. Now to form what? N2 minus. Now what about the second electron gain enthalpy? It is positive. Second electron gain enthalpy is positive. Why? Listen carefully. Now here it is 7 electrons is there. Alright? 7, atomic number 7. 7 electrons is there. It gains one more electron. So number of electrons here, it is how much? 8. Here the number of electrons is 7. So what you find is that nuclear charge does not increase. Rather, electrons in the outermost shell increases. The electronic charge increases. Nuclear charge is not increasing, because nucleus, in the nucleus there is protons is how many? 7 only. Here also the protons is how many? 7 only. Electrons is increasing. So hence the electronic charge increases. When the electronic charge increases, the repulsive forces increases. Because in the outermost shell there is 5 electrons was there. 5. Isn't it? Here 5 electrons is there. By gaining electron it becomes 6. So 6 means the repulsive forces, don't think that 6 means repulsive forces will be there. No. In this case I am saying you that here the nuclear charge is not increasing. Here the electronic charge is increasing. Electronic charge means what? The electrons which is present in the outermost shell, that charge is increasing. Definitely. So when that charge is increasing, means from the normal to that 1 electron is increasing. What will happen? The repulsive force is going to increase. Due to increase in the repulsive forces, when you are going to add the second electron, now one more electron when you are going to add it to it, you have to overcome these repulsive forces, then only you will be able to add an electron. Listen carefully. If you are adding an electron to here, to this particular N minus, you have to overcome the repulsive forces. You have to overcome the repulsive forces, then only you will be able to add an electron to it. Got it? Then overcome means you have to supply energy to it. Alright, then only you will be able to add an electron to it. Alright, so what I said, you have to supply. Supply means endothermic, absorbing. So in this way, the first electron gain enthalpy is negative, the second electron gain enthalpy is positive. Now suppose the next electron gain enthalpy, N2 minus, let us say, plus E minus, it forms N3 minus. Still it is highly negative. Highly positive. It is highly positive, because here the repulsive forces is much more than this. So to overcome, you have to give large amount of energy. Then only you will be able to add an electron to it. So here in this case energy is absorbed. Here also in this case energy is absorbed. So hence remember it. The first electron gain enthalpy is negative, but after that the successive electron gain enthalpy is positive. Okay? Thank you.